Just like Jodie Foster's character in the movie Contact, scientists have come across a mysterious signal from a galaxy far, far away.
Billion light years away, or in scientific terms, really, really far, burst of energy coming through the cosmos.
In our continuous search for life in the cosmos, a recent discovery has been made, which could change how we see the universe as a whole. A radio signal has been detected from the heavens. But this isn't just any signal. It's a signal that carries a potential signature of a magnetic field, similar to the one we have on Earth. This signal is being transmitted from a rocky, distant exoplanet orbiting the star known as YZ Ceti. Does this mean that this exoplanet could contain a habitable environment? And what could it teach us about the presence of life out there in the vastness of space? Join us on this journey as we travel through the stars in order to understand what this planet might be hiding from us. Radio signals are a type of electromagnetic radiation, like light, X-rays, and microwaves. Radio signals can be created by stars, galaxies, as well as spacecrafts, satellites, and other man-made objects. Because of their ability to carry information through long distances, they have revolutionized the way we communicate with each other or send data. Radio signals have become one of the most important technological advancements that we use in our day-to-day lives. Being able to harness and comprehend radio signals made it possible to develop GPS systems, which are used by almost every person who has a smartphone. It is also used in weather forecasting and tracking various tropical storms that could potentially cause destruction on a massive scale if they aren't detected at the right time. But these are examples of artificially generated radio signals. Similar to them, naturally occurring radio signals in the distant regions of our cosmos carry just as much potential to change our lives, if not more. Like other electromagnetic radiations, radio signals travel at the speed of light, traversing expansive distances throughout the boundless void of space, which makes them one of the best cosmic messengers of our universe. But how do we gather these radio signals, and how do we make sense of the information they carry? The answer is through massive radio telescopes and using the science of radio astronomy. If understood and interpreted correctly, these radio signals can tell us about various stars, what they're composed of, what planets orbit around them, and even further back to the birth of our universe. Radio telescopes like the Very Large Array in New Mexico are designed to do this with great precision. They act as an extension to our human ears, picking up the faintest of all radio signals out there in the distant cosmos. Once a radio signal is picked up, it is analyzed extensively using algorithms and data models. The detailed information gathered from them helps us understand various facts, like where it originated from, how far away it could be from Earth, and what physical properties its source might carry. Within the constellation of Cetus, the sea monster, lies a star that has been transmitting a very peculiar signal that might be concealing some information. The name of this star is YZ Ceti. YZ Ceti is a red dwarf star, much smaller and cooler than our Sun, and located just 12 light-years away from Earth. YZ Ceti might sound interesting, but what's even more fascinating is one of the planets that orbit this star, YZ Ceti b. A total of 3 exoplanets orbit YZ Ceti, including YZ Ceti b, which is the closest planet to the star. In fact, it is so close that the time it takes to complete one orbit around its parent star, also known as its year, is equivalent to 1.6 Earth days. This close-by neighbor of YZ Ceti is more or less the size of our Earth and has a rocky terrain. But that's not the most interesting fact about this exoplanet. Recently, using Very Large Array, Professor Jackie Villetson and her colleague J. Sebastian Pineda at Bucknell University detected a repeating radio signal originating from YZ Ceti. This signal was recorded at a frequency of 2 to 4 gigahertz, and this appears to be modulated by the rotation of the star and the orbit of YZ Ceti b. This means that there might be a magnetic field around the exoplanet which could be interacting with the star. The presence of a magnetic field around an exoplanet sounds like a massive discovery in itself, But what's even more groundbreaking is that it could provide more insight into exoplanets and how their magnetic fields function. The presence of a magnetic field could mean there is a possibility of life on an exoplanet, or at least it is able to harbor some form of living organisms. However, it is unlikely that YZ Ceti b has an abundance of organic life due to its extremely close proximity to its parent star. So, what makes magnetic fields this important for the survival of life on a planet? Well, it's simple. Think of the magnetic fields as a form of shield, protecting the life on the surface of the planet from harmful radiations such as solar and cosmic particle radiation, as well as devastating solar winds, which could erode the planet's atmosphere, turning it into an inhabitable barren land. Without the Earth's magnetic field, life as we know it would never have existed. In addition to the protection our magnetic field provides us, it also helps us, as well as other animals such as birds, to navigate around the planet more effectively. But that's not all. Magnetic fields fulfill other functions throughout our cosmos as well. It helps in the formation of galaxies, redirecting the movement of interstellar gas, and helps by influencing the formation of new stars. Because of their vast functions, the search for magnetic fields throughout the cosmos and on exoplanets has become a necessary quest in the exploration of life. As we said before, radio signals are a type of electromagnetic wave, which means, by nature, they are composed of oscillating electric and magnetic fields. These fields interact with other magnetic fields throughout space, altering the radio signals in a multitude of ways. One of these changes is called deflection, in which its direction can be completely changed. The frequency of the wave can be shifted, and the polarization or orientation of its electric field can be rotated. Studying these changes in the radio signals, scientists can deduce various properties of the magnetic field that it passed through, such as the strength and orientation of the particular magnetic field. However, magnetic fields aren't always a good influence on radio signals. They can be somewhat counterproductive to the whole process of detecting these signals by causing an interference or even distorting it beyond recognition, making it hard to interpret. Because of this, magnetic fields act as a double-edged sword in the detection and analysis of radio signals, making them an integral chapter in radio astronomy. Being able to understand magnetic fields and what effects they can impose on various signals from distant exoplanets can help scientists extract valuable data, as well as correct distorted information traversing through them. Unlike Earth, the red planet Mars has a very weak and inhomogeneous magnetic field. This is thought to be because of the lack of a dynamo in its core. A dynamo can be understood in simple terms as a rotating and electrically conducting fluid within the core of the planet, which maintains its magnetic field. Earth does have a dynamo in its core, and therefore it has a strong magnetic field. But in the case of Mars, its weak magnetic field is due to the remnants of magnetism trapped in the planet's crust from the time when Mars had a strong global magnetic field. Mars was said to have contained an early dynamo somewhat 4 billion years ago, and it created a strong magnetic field, comparable to Earth. But now, without the protective shielding of a magnetic field, Mars's atmosphere is subjected to the harsh lashings from solar winds, which have eroded it over time. The model presented by YZ Ceti at the University of Tokyo suggests that a weak magnetic field, such as Mars after its dynamo was turned off, can cause more rapid atmospheric erosion than in the case where there is no magnetic field at all. Through this model, it can be seen that planets with weak magnetic fields can lose their atmospheres 6 times faster than those that do not contain any magnetic field whatsoever. This means that because of the shutdown of the dynamo within the core of the red planet, it rapidly started losing its atmosphere due to the bombardment of ionic particles, and this process was even accelerated by the weak inhomogeneous magnetic field present in its crust, turning it into the inhospitable, barren, lifeless planet that we know it as today. This process of losing the atmosphere over billions of years is known as atmospheric stripping. All this means that Mars could have potentially been a warm and wet planet, somewhat similar to Earth before it became the rocky, cold, red planet that we are familiar with now. Exoplanets, meaning the planets orbiting various other stars outside our solar system, have turned into a major focal point in order to understand how life could have formed. As of now, we have cataloged more than 1,000 different exoplanets, and each of them could teach us something different regarding the formation of life that we may not be aware of. One of the most interesting of them was the discovery of the first known magnetic field present on an exoplanet, which is the size of Neptune. This was done with the help of the Hubble Space Telescope, used by a team of international astronomers in December 2021. The name of this planet is HATP-11b. Located a significant 123 light-years away from Earth in the constellation Swan, this massive planet is considered to have extreme temperatures. This is due to its close proximity to its parent star. This discovery changed the way we looked at exoplanets as a whole. Not only did it make us understand that exoplanets can have the ability to generate strong magnetic fields, but also that they can be considered in the search for habitable planets, which could contain life. The same is the case with the exoplanet we started from YZ Ceti b. If the radio signals we detected are an indication of a magnetic field around the exoplanet, this could teach us how a strong magnetic field can function on various other planets, as well as how it is formed, or what potential factors can lead to its complete degradation. Perhaps studying them would provide more insight into what really transpired on Mars and how its dynamo shut down completely. It could also help us pinpoint other exoplanets which might consist of life in distant galaxies we believed weren't capable of sustaining life at all. Even more so, this could eventually lead to our understanding of how inhabitable planets could be terraformed in such a way that an atmosphere could be built around any planet and human life could thrive on its surface, although the science of it is still in its infancy. Thank you for watching.